Hello, this is lesson 13.4a on refraction for physics 30. Taking a look, what is refraction? Refraction is simply the bending of light as it passes between materials of different density. What that is that you will have an index of refraction, that's a ratio of the velocity of EMR material compared to the speed of light. C over V, that should say C, make that adjustment there. C is the speed of light in a vacuum. Right? And so this index of refraction we often refer to as N. It is a ratio of how fast something is. So if something is moving slower, so if light is moving slower here than in a vacuum, let's say this is in the vacuum, and it's slower in this material, you'll notice that that index of refraction is going to be greater than 1 because C is going to be faster or a bigger value than V, right? Because C will always be bigger than V. Okay, so we have different indexes of refraction. Air is 1.0, water is 1.33, glass 1.50, and diamond, that is 2.42. Kind of looks like a 9 there, but that should be a 4. 2.42. All right, now as we take a look at these, you don't need to actually memorize these. However, in many questions, including your homework questions, you're going to be assumed that you have access to this chart on quizzes and tests. You're either going to be given this information, or you're going to be looking for it, or it's going to be irrelevant to the question. Now, this will, because of the slowing down of light as it moves into the medium, or the speeding up as it moves out of a medium, it's going to bend. And so when it slows down, it actually will bend towards the normal. And when it enters something less dense, it speeds up and bends away from the normal. So here we have our incident ray. And the normal is just that dotted line perpendicular to the surface, and so the angle of incidence is between that incident ray and the normal. Here's our incident ray again. The angle here, the normal is just this dotted line. Angle of refraction is going to be that angle between the normal and the refracted ray. As light enters from air to glass, it's bending towards the normal. As if light bends here away, here we see light coming towards the normal. It bends towards the normal as it enters glass, and it bends away as it leaves the glass. Right? Similar thing to happening with water going from air into water. You'll notice that the angles are slightly different. It doesn't bend quite as much, but you still see the same thing where it bends towards the normal as it enters in the more dense medium and away as it moves to the less dense medium. So in which of these cases is the medium more optically dense? I should say in which medium 2 is more optically dense. Well, that would be this one and this one, because they both show that it's bending towards the normal. In which case, 1, 2, or 3, does light travel fastest in? Well, that would be the first one in medium 2, as this says pulling away from the normal. And so light's going to be traveling fastest there. Now, in order to solve these problems, we're going to use Snell's law. Snell's law states this formula. It is on your formula sheet, so you don't need to memorize it at all. But you're actually just taking two components. And the 1s and 2s stand for the mediums. That's it. And you can label any medium 1, any medium 2. It's just that you have to be consistent within the problem. So if we take a look at what is the speed of light as it passes through water, well, we're aware of the indexes of refraction, and we're looking for the velocity, so we're going to use this portion of the formula. So n2 over n1 is equal to v1 over v2. Now, because we're looking for the speed of light passing through water, we will call v1 in water what we're looking for, and v2 being 3 times 10 to the 8 meters per second. We're choosing that medium 1 to be water. Mathematically, it just makes it easier. Now, if we chose n2 to be water, that would be fine, but it's easier for us to just choose that to be air. So when you take a look at the equation, you have 1.33 over 1.00 is equal to v1 over 3 times 10 to the 8. Now I've got that backwards. 1.00, 1.33, right? Because n1 is 1.33, that's on the bottom, and 2 there. And so 3 times 10 to the 8 multiplied by 1 is just 1, divided by 1.33 is equal to v1, or 2.25 times 10 to the 8 meters per second is equal to v1. Let's take a look at a second example here. This one we're looking for the angle as it's in diamond. Again, we know the angle of incidence and the index of incidence and refraction, but we're going to call n1 to be diamond because we're looking for the angle in diamond. n2 is 1.00. Theta 1 is going to be what we're looking for, and theta 2 is 45 degrees because as this is entering from air into diamond, it's coming in at a 45 degree angle. We know it's going to bend towards the normal because it's more dense. We just want to know what this angle is. We're going to call diamond medium 1 and air medium 2 because mathematically it's going to be easier. Right? If you switch them up, it's going to be just fine. So we're using the sine and the indexes of refraction. So we're looking for that angle. Sine 45 is equal to n2, which is 1.00 over 2.42. Multiplying both sides by sine 45 gets you this equation. And as you solve for theta, remember it's not just sine 45 divided by 2.42. You've got to inverse that sign, but you're going to find that angle is equal to 17 degrees, which is expected that it would be lower than 45 because this is in fact bending towards the normal. Taking a look at example number 3 here. What is the index refraction of substance D? We don't know what substance D is, so we're looking for it. We're going to choose substance D to be N2 here, right? As it leaves air, so air is going to be our substance 1, 1.00. The angle of incidence as it leaves substance D. So if we think about this, it's leaving substance D, going into air. That is 41 degrees, right? So in this case, angle 2 is equal to 41 degrees. And we're 41 is in air, it's at 53.2 degrees. So we're using the same equation as last time, but now we're looking for n. So sine theta 1 over sine theta 2 is equal to n2 over n1. Sine 41 over sine 53.2 is equal to n2 over 1. Now you'll notice that because it's over 1, really we can just cross that out. And you're calculating this, which if you type it in your calculator correctly should get you 1.22. So pause the video, give this one a try, see if you've got it. Pause the video, take a look. Okay, welcome back. You should acknowledge the fact that you are looking for a wavelength in this case, and finding wavelength 2 is going to be easy. Is going to be the easier route, and you'll find that that is going to be 3.3 times 10 to the negative 7. So that is just slightly shorter than violet light, so that means this is going to be a UV light at this stage, just beyond what humans can see. Now, as light moves in from a more dense to a less dense, there's actually going to be a critical angle, where that angle of refraction is 90 degrees. When it's 90 degrees, right, it's bending basically as much as we can. If we think of this as water and air being less dense, you get to a point where it comes straight across here. The light reflects off if it's anything greater than that for an angle of incidence, and it's contained within the boundary. In other words, you see internal reflection. It's a common use in fiber optics and other things where light will travel through glass with total internal reflection. It just bounces off the sides of the glass. It doesn't actually escape, even though it's a glass boundary. So we see here in this diagram, we've got an angle of incidence of 90. It just comes straight out. As this angle increases, eventually get to a point where that angle of refraction reaches 90 degrees. Anything greater, it doesn't refract, it reflects. So what is the critical angle of light diamond against air? So it's a critical angle, so we're going from more dense to less dense. So this is diamond, this is air. And we're looking for that critical angle. This angle here, which gets you an angle of 90 degrees. By definition, that is what we mean by the critical angle. Okay, so sine theta 1 over sine theta 2 is equal to n2 over n1. And it makes sense for us to use diamond as n1 because, again, we're looking for this angle. All right, so sine theta over sine 90 is equal to n2 is 1.00 over 2.42. Now, sine 90, when you type in a calculator, actually is just 1. And so when you multiply 1 by sine 90, you actually do get 1. That is not a typo in your calculator. 1 divided by 2.42, that gets you 0.143, and again, you're going to inverse sine that, right? So you're going to inverse sine both sides, and that gets you an angle of 24.4 degrees. All right, hopefully that helps. If you do have any questions, let me know, and have a great day.